At all of you. Once again, good morning, all of you, and good evening as well. Okay, so hope everyone is settled. So let's start. So in the last class, we were talking about object-oriented concepts. That is where we stopped, and we have discussed about various object-oriented concepts, right? So what are like? Could you please recollect once what we have discussed regarding the objects? Yes. See, as I told you people, object-oriented concepts are derived from the real world, the world in which we live. This is completely based on object-oriented concepts. So in object-oriented concepts, object plays a key role. So object means anything in this world. Anything you take in this world is an object. An object has got characteristics. Object has got characteristics. So what are the characteristics of an object? Yes. So what are the characteristics of an object? So every object has got properties and behaviors as we discussed. So properties they describe an object, whereas behaviors they define the actions performed by the object. And we are talking about object-oriented features like inheritance, and we have discussed about polymorphism. So inheritance, yes, it represents a parent-child relationship between the objects, and this is one of the features as we have discussed. And polymorphism, poly means many forms, right? Poly means many, morphism means forms, many forms. Okay, so these are the things which you have discussed so far. So today we'll carry forward our discussion. So first of all, let me talk about the associations. You know, generally people won't mention it, but definitely I would like to talk about it. So when we talk about objects, you know, objects, you'll find that in this real world, if you consider objects, you'll find that objects they collaborate with each other to accomplish a task or a goal. Objects in this real world, you see, they collaborate with each other to accomplish a task or a goal, right? So one object can be associated to one or more than one object. An object can be associated to one or more than one object, I can say. Yes. I'll give you some examples for this. For example, okay, and you see, objects have got associations, I can say, and the associations can be simple associations between the objects. Simple associations. For example, you consider a savings account object and to this object you'll find that another object is associated, account owner or account holder, I can say account holder, let's say. So account holder and savings account, you see these are two objects and they are associated. How? Account holder holds an account or owns an account in the bank, right? So now similarly account holder now will collaborate with several other objects to accomplish a task or a goal, I can say. For example, if you consider withdrawal of amount, account holder wants to withdraw the amount from the account. The account holder wants to withdraw the amount from the account. So now the account holder is an object. Now account holder will take the help of another object called as teller. Teller. So teller, a person who sits in the branch, okay, in the bank branch, and will help the account holders or customers to draw the amount from their accounts. So you see, account holder now will take the help of teller, right? So teller is another object, a person who helps the account holders to withdraw the amount. So the association between account holder and teller is a simple association, I can say. Okay, it is very simple association. Just a simple interaction occurs between these two objects. Yes. But when we talk about associations, associations can be composite. The associations between the objects can be composite or composition, I can say. Yes. Composite means, you see, you'll find that in this real world, if you observe the objects can be made up of several other objects. Objects can be made up of several other objects, I can say. For example, yeah, you take any object. Yes, for example, let's say car. So car is made up of several objects. Car has got an engine, car has got a steering wheels. You see, these are all several objects here. Steering wheels, engine, air condition, AC in the car. So these are all objects. So the car is made up of several other objects, I can say. Yes. You see, engine is complex enough to be called as an object, right? So yes, air conditioner is also an object. It is complex enough to be called as an object. They've got properties and behaviors, right? Those objects have got characteristics. So this way, objects can be made up of several other objects. You see, again, in this type of composite associations, I can also call it as a whole part association here. So the other name I can call it as whole part association. Whole part means one object is part of another object. So the example is car and engine. The example is car and engine. So car is an object, it's a complete object in which engine is part. Engine is part of the car object here. You see, one object is part of another object. It's one object is part of another object. Yes. Okay. So Later on, you'll find that we have again special type of composition called as aggregation. So we'll discuss about it. So these are all the features of object-oriented features, you know, which you'll see in the real world objects, and we have to implement them. Okay, in the programming, yes, we need to implement all these concepts, whatever we are discussing in the object-oriented programming in Java, we will implement them. Okay, yes. Next, we got abstraction. So how do we define abstraction? Yes, so most of you people might be familiar with it. Abstraction. Okay, abstraction means, okay, I got several answers. If you find that the answer is lengthy, you can just unmute and talk to me. Don't hesitate. So hiding. Okay, I got one answer as hiding. Methods which can be modified. I want you people to just give me some examples which you see in this real world. Because as I told you people, the object-oriented concepts they have been derived from this world, from this real world itself. The world in which we live, it is completely based on object-oriented concepts. We try to relate this. So what is abstraction first of all?
It would be a method which you can't really change later. It could be protected maybe.
Okay,
It could also be used for particular classes which you create for different objects if you don't want them to be changed by outside sources. Not
okay,
entirely.
okay. Yes, I got one answer, and I got another answer here from Rupa. Car can be a bench or a boomer. Okay, okay. So first of all, let me define this abstraction. So abstraction is all about concealing the internal details or irrelevant details, I can say, and revealing only the relevant details. Yes, abstraction is all about concealing irrelevant details and revealing relevant details here. Yes. So, okay, you will find that the abstraction concept is widely used. Sorry, you'll see that abstraction concept is all over the place here in the real world. So, this complete world is based on abstraction itself. So, we can't think about anything, any object without abstraction. Yes. So, as I told you people, concealing or hiding irrelevant details, only revealing the relevant details. Yes. For example, okay, you people give a car. You know what? Here, any object is based on this abstraction concept, I can say. Yes. Any object is based on the abstraction concept. For suppose, let's say you bought a car, a new car. Now you see, in order to drive that car, You don't need to be a mechanical engineer, right? You need not be a mechanical engineer in order to drive that car. Yes. So you don't need to understand the complex mechanism which drives that car. No, you don't need to understand how the engine works and all such things, right? So, but still, even though you're not familiar with those things, how the engine works and all, still you'll be able to drive the car, right? So, because those details are concealed from us, they're hidden from us. Yes, uh, you know, we got an abstraction or that complex mechanism, I can say. So, here, in order to drive a car, you need to know how to switch the gears, how to control the speed using brakes, how to accelerate, how to move the car, how to accelerate, how to control that speed using the brakes. This is what you need to know, right? You don't need to be a mechanical engineer to drive the car. So all you need to do is how to switch the gears. You need to know that how to control the wheel, how to accelerate, how to how to control the speed using brakes. If you know this, you can drive the car. If you know this, you can easily drive the car, right? So that complex mechanism is concealed or hidden from us. So that is abstraction. Fine. So now can you people give me some more examples of abstraction? Where do you see that abstraction concept in the real world?
All electronic books.
All electronics. Okay. Yes, that's right. You see, you take any. Okay. Yeah, a vehicle can be made but it can have car or bike subclasses. Okay, using a laptop. Okay, yes, using a laptop. Yes, that is another example. And yeah, mobile phones, anything, any object. You see, every object in this world is based on abstraction concept. I can say the televisions, TVs. You got smart TVs, right? So even they're based on this abstraction concept itself. Mobile phones, laptop, yes, your bike, everything. You know, yeah. So food on your table, yes, yes, anything. That's right. Okay. So the GPS which you people use, right, in your cars, we really don't know how the navigation system works, but still we're able to use it. Yes. Okay, just a second. So at the end, we are saved from a lot of difficulties, a lot of complexity, right? Yeah. Okay, fine. So that is abstraction. Even that abstraction concept is used a lot in Java. Okay, in the object-oriented programming, I can say. Yes. Next, okay, we got encapsulation, but this part I'll talk about it later. Okay, in the programming itself, I'll discuss about it. Yes. Okay. Yes. So these are the features which you see in the objects, right? So fine. Now we got some idea. Actually, these concepts are not new to us. So these are the concepts, which are part and parcel of our life. Yes. So uh, we are also based on this concepts itself, I can say. Yes. Fine. Now here comes the application part. How do we apply this object oriented concepts in the programming? How do we apply the object oriented concepts in the programming? That is what you need to learn now. Yes. So we'll try to implement these concepts. Okay. And most of you people might be thinking here, you see, this guy Mahesh is talking about object oriented concepts, but he never mentioned about a class. Did he miss that class? Yes. So what do you people think about a class? How can we relate this to the object oriented concepts? Because of course, you people might have heard about it, that okay, class, this is one of the most common things which is used in the object oriented programming. How can we relate it to the real world? Yes. So this class, yes. What do you people think?
Set of objects, a collection of objects.
Class, okay, it represents a group of similar objects, I can say. Class, I can say that it represents a group of similar objects. You see, objects can be many different types of objects. Based on the properties and behaviors, we can further classify the objects based on the properties and the behaviors. We can further classify the objects here. So that classifications, every object, it belongs to a class, a group of objects, with similar properties and behaviors. They belong to a class, I can say. Yes. Fine. And we'll be using it. Yes. Okay, you see Neil gave one example here. Yes, good. Yeah, you see the English language as a superclass, but have dialects. Yes, Australian, Indian, American. Yeah. Okay. Or you can say the better example for classifications or classes, like you see human beings is one class. Or you can say language instead of English. Yeah, that is also right what you said. We need not talk about super and sub here, but you can say English. You see, again, when we talk about English, yes, you got classifications again. Yes, British English. Okay. Yes, US English, Indian, Australian. Yes, it will be slightly different, of course. So similarly, you consider the various classifications which you see: humans, right? Animals. Okay, birds, and again you have this classification: birds. Okay, vehicles. So how we are classifying these objects here based on the based on the properties and behaviors. So all the objects which have got similar properties and behaviors, we'll group them together. Yes, fine. That's it. But again, when we implement it in the programming, yes, we'll see how it works once again. So now we'll consider a small example and we'll try to understand how we implement this object-oriented concepts in the programming. Yes. So let's say you're part of a team which is developing an application for a bank. Okay, you're part of a team which is developing an application for the bank. Yes. Now you have been given a task. So what is your task? You have been told to define to write a Java program, you're supposed to write some Java code here, a Java program, which will store that savings account details into the memory. That savings account object is the Java program which you write, it is supposed to store the savings account details into the memory. So how will you do that here? So you got savings account object whose details we are supposed to store in the memory. So I'm talking about savings account of a bank here. Okay, we have to store this real world savings account object details, I can say. You got an object whose details you have to store using a Java program. So how will you start? What do you people think? Yeah, so let's see. Don't worry, I'll tell you people. So if you're supposed to, or if to write Java code to store a real world object details, then in Java what you're supposed to do is you need to create a Java object here. You need to create a Java object. The first thing here, whenever you're supposed to store a real world object details, let's say you've been given a task to store the details, so immediately create a Java object. So what is this Java object here? Java object, you can think of it as a software object also, because we write the program to create this object. Yes, it's just a software object. So basically this Java object here which we create, so it is going to represent a real world object. It represents that savings account object, real world object. So when I say details of the savings account object, what it includes, details means I can say they are nothing but properties. You have to store, you have to actually write a program to store these properties or property values of the savings account object here. Yes, the properties includes account number, balance and all. Yeah, so these are the details. Let's say you may have other details as well, but let's consider these details as of now. Okay, so first of all you need to create a Java object. So this Java object, I can say that Java object is a software object. It represents a real world object, I can say. It holds the data related to the real world object. Yes, it holds the data related to the real world object here, I can say. Fine. So you need to create an object, but you know what, here can we how do we create an object? How do we create an object? So in order to create an object, we need to first Before we create an object, first of all, we need to define a class. So what is a class? A class is a template for creating Java objects. Class is a template for creating Java objects, I can say. Yes. In other words, I can say that a Java class is a blueprint of an object. So here we can add one more point here to the Java object. I can say that Java object is an instance of a class. It's an instance of a class, and the Java class here, class, represents a group of similar objects. A class basically it represents a group of similar objects here. So now to make you people better understand the relationship between Java class and object, let me take an example. Class versus object here. You see, from now on, I will not use the term Java class or Java object. I'll simply say class. When I say class, I can say that I'm referring to that Java object itself. When I say class, basically I'm referring to that Java object. Sorry, Java class. When I say class, I'm referring to Java class. When I say object, I'm referring to Java object here. So the relationship between a class and object is similar to the plan versus a building. Okay, building. You see, for example, here, let's say you want to construct a building. So in order to construct a building, so what is the first thing you'll do? You need a plan. Okay, uh, you'll approach engineer and will give your requirements. Based on the requirements, engineer is going to draw the plan for that, right? Yes. So basically, what is a plan here? Can you people tell me? Just let me know whatever you know about this plan. Just a plan in general. Basically, what exactly have in a plan? So okay, it's a drawing, and in the plan you have the complete details, you know, about the specifications about that building, right? You got the specifications about that building, and based on that plan, your constructor or builder is going to construct the building. So if you hand over the plan to the constructor or builder, simply the constructor is going to construct the building here, I can say. Yes. Okay. And based on a plan, how many buildings can we construct?
Many buildings.
So, n number of buildings, right? Many. Yes. So a plan can be used to construct. Sorry. A plan can be used to construct any number of buildings. Yes, that's right. So you see, a similar relationship exists between a class and an object here in Java. So if you want to create an object, first of all you need to define a class. A class is a plan for that object, I can say. It's a plan. You can think of it as a plan of an object. So the way you got the complete specifications about the building, the dimensions about the building, each and every detail about the building in the plan. Similarly, the class contains set of details about that object. It describes an object here, I can say. Yes. Okay. So, and basically, why we create objects? Through these objects, I can say that we are trying to simulate the real world objects here. We'll try to simulate the real world objects. Yes. This Java object is going to represent a real world object. Yes. Fine. So now in our example here, let's say, as I told you people, you got savings account objects, real world savings account objects, the account objects which we see in the bank. So you've been told to write a Java program to store the savings account objects. So how will you start? So first of all, the first and foremost thing, when we talk about details, they are nothing but the properties of an object. The details here, they represent the properties of an object, I can say. And what are the properties here? You see, you have to identify the properties, account number, balance. You may have other details also which you would like to store. Let's say PIN number, PIN. Yes. Let's consider this example, this properties here. So once you have identified the properties or the details, what details you have to store regarding that object, the next thing what you need to do is, yes, are we supposed to create an object or class first? A class. So basically we need an object here. We need a Java object to store that real world savings account details, you know. But the thing is, in order to create an object, first of all, we need to define the class. Yes. And that class basically it acts as a template for creating Java objects here. Okay. Yes. So let's define a class here so that we can store that real world savings account object details. So for that, you see, we got the project which you created earlier. Let's make use of it. So you got the source folder here. I'll right click on it. And you see, you got new class option here. New class. So I'll select this. And the class name, I'll give the name as savings account here. Savings account. So you can give any name to this class. But the thing is, because this class is going to represent savings account objects, we'll name it as savings account. But if you want, you can use any name you wish. Okay, now I'll click on finish. Okay, you see, this is just a simple Java class. That's it. So what is the next thing? After defining this class, now we need to represent the properties of that object. What details you want to store? You see, these are the properties. which represent the details of that object, as I told you people. So what details we are supposed to store here? So I would like to store account number, balance, and PIN. So these are the properties, right? So the properties here, they are represented as variables in the class. The properties of an object, a real world object here, they are represented as variables here. Why variables? Because you see, these variables, they're going to hold the property values. This variables itself, they're going to hold that property values, I can say. Okay, so we'll consider this variables. Float, balance, and PIN. That's it. Okay, so you see, each property of an object, it is represented as a variable. So actually, the term, proper terms which we use here is a field. You can call it as a field. So the variables which we declare in the class, they're called as fields, or instance variables, or so we call them as non-static variables. Non-static variables. You can use any term. So these variables which we declare in the class this way, see, not inside any method. Earlier we have defined methods, and inside the methods we used to declare the variables, right? But now you see here, we have declared that variables directly in the class. Yes. Okay, then what's the next thing we are supposed to do? Now we got a class, I can say, though this is not a complete class, it's an incomplete class. Let me admit it. So it's not a complete class, but still we can make use of it. Okay, I can say that now we got a template here, so which we can use to create objects. Yes, what objects? Savings account objects here. So let's make use of this class and create a savings account object. So what is the purpose here? Why we want to create an object here? Yes, so that we can store the real world object details, so that we can use it to store real world savings account object details, to store the savings account object details. Yes, that's right. Yeah, so now let me instantiate that class. That means let me create an object for that class here. So now who will create the objects for us? JVM is going to do that. So I'll request the JVM here to create an object. So this statement is going to do that for us. This statement will do that for us here. So what is the statement? You see, using that statement, it's an object creation statement, I can say, and we are using the statement here to ask the JVM to create an object. So now the JVM here, it creates an object, I can say. The JVM is going to create an object. Yes. So when it does that here, what happens in the memory for that object, for that savings account object, a block of memory is allocated. A block of memory is allocated. A block of memory is allocated. And as part of this block of memory, the memory for the variables is also allocated. So what are the variables which we have declared in the class? For that variables, the memory is allocated this way: account number, balance, and pin. Yes. So this way the memory will be allocated for these variables as part of that object itself. Yeah. And the reference to this block of memory, basically this block of memory itself is called as an object here. We can say that this block of memory itself is called as an object, and the reference to that object is stored in a variable whose name is account. I can say that here, that variable called as account, it will be referring to this object here. So it acts as a handle or a pointer or a reference to that object, I can say. Yes. So this is what happens when the JVM executes that object creation statement here. Now you see, we can store the savings account details into this object now. We can store the savings account details into this object. And how do we access that object here? Using that reference variable account. You got account, right? It's a reference variable which is used to access that object. It's a handle or a pointer to that object here, that account. Yep. So that means if you want to access this variables, you see the variables which are part of this memory block, they hold the values. Now we can store the values into this variables here, and in order to access this variables, you have to use this reference account reference. So for example here, if you want to access that account number, then do this account dot account number, and you can assign some value, let's say 101. And similarly account dot balance, say 5000. And similarly account dot pin 1234. That's it. That's it. So this way, you see, you can access the variables which are part of that object and assign the values to that variables, or store the data into that object, I can say, in other words. So now what happens? The data will be stored into this variables here. So 101, 5000, 1234. Okay. So this is what happens. Fine. Okay. So what we did, now we have created a Java object. As part of that object, you got some variables. Into that variables here, we have stored some data, and the data is related to a savings account object here. You can see the data is actually related to the savings account object. Yes. Fine. Now how do we read the data from that object again? So again, you have to use that reference itself account. You have to use that reference account. You see, I can do that. So first, let me just add some label here. It's account number. Just some text content will display it before displaying that value. Now I'll do this account dot account number balance account dot balance and the pin here account dot pin. That's it. So this way, using the reference here, you see, again we can access the object. Not only the object, the properties or variables which are part of that object, you can access them. Okay. Now let me run this code once. Fine. You see, you got the data. Now that block of memory, which we call it as an object, it holds that data related to a real world object. Why we are calling that block of memory as an object? Because that block of memory itself, it represents that object. I can say it holds the data related to that object. It holds the data related to a real world object and represents a real world object, right? So that's the reason why the block of memory itself is called as an object here. It is called as an object. Yes. Fine. So now what if I got another savings account object? I would like to store that savings account details. What to do? Let's say we are supposed to store another savings account object details. So what to do here? Okay, create one more object to savings account. Create another object. Okay. So I've got a couple of answers. Both have got the same opinion. That's right. You see this object which we have created here, we cannot use it to store another account details. Yes, we cannot use it to store another account details here. So an object can only take or can hold one. In this object as of now we can only store one account detail, one savings account details here. Yes. Okay, yeah, let's do that. I'll create another object here. So again I'm going to use this object creation statement. The reference variable name this time it will be account2. It will be account2. That's it. Okay. So now I can say that when the JVM executes the statement, so it creates another object. That means it allocates a block of memory here for another object this way. And as part of that object also, you'll have the memory allocated for that variables which are declared in the class. So this object here will be referred by a reference variable account2 is okay. So this is what we're doing now. So we are creating another object so that it can be used to store the details. Yes. Now in order to access that second object, so you need to use this reference account2 to access the second object. You need to use that reference account2. So let's say account2 dot account number this way. Okay. Yes. Account2 dot balance. Account2 dot pin. So this way, you see into that object, into the second object, we are storing another account details here. That's it. This is what you do. For suppose here, I got 100 savings account details which we have to store here. So we are supposed to store 100 savings account details. So how many savings account objects are we supposed to create to store 100 savings account details? How many savings account objects do we need?
I'm sorry, what was the question?
You need 100. Yes, you need 100. For each object, just for each savings account details, we'll create one object. Okay, so there won't be any problem in this regard. Okay, we can create any number of objects. Yes. Okay, fine. So now you have to understand one thing. What is it? You see that instance variables which you got in the object. You see, for suppose in the second account object also you got this variables. The memory for this variables is allocated. So what is the amount? So 6,000. Say 4, 5, 6, 7. So yes, now you see here, each time we create an object, the memory for that variables, it is also allocated separately itself. You see, every object will have a separate copy of this instance variables here. Every object will have a separate copy of this instance variables. As of now, we have created two objects, so we got two copies of this instance variables. We got two copies of instance variables. Similarly, if we create 100 objects, then we'll have 100 copies of that instance variables. We'll have 100 copies of that instance variable here. Uh, that means every object will have its own copy of that instance variables, or non-static variables, I can say. Why we need a separate copy of that variable in every object here? Yes, what do you people think? Why we need a separate copy of that variable in each object? Because, yes, that's right. Because you see, the data related to this objects is going to be different. No two objects will have the same account number. No two objects will have the same balance or pin, right? So the data will be different. So that's the reason why you need a separate copy of this variables itself to hold that data. Okay. So that is what you need to understand here. Every object has got its own copy of that variables. Now, for suppose if I want to access that copy of variables, sorry, uh, if I want to access the copy of variables which are in the first account object, then what to do? If I want to access the copy of variables in the first account object, then what to do? Yes. So if I want to access the copy of variables which are in the first account object, then use that first account object reference. What is it? Account, account, account. How will you read that copy of variables which are in the first account object? Use that account reference variable. You see, I'm doing it here. Account dot account number, account dot balance. What is account? It's a reference variable, okay, which holds the reference to that object or which refers to that object, I can say. And this is similarly, if you want to access the copy of variables which are in the second account object, so you have to use the second account object reference. You have to use the second account object reference here. So this is how it is going to work. Okay. Yes. Uh, just a minute, please. I'm sorry. Give me 1 minute. Just a minute. Yeah, sorry. So can you people hear me? Are you people able to hear me? Okay, fine. So now we'll dig into the details of this object creation statement. Okay, so it's important to understand the object creation statement. We'll dig into these details here. Yes. So if you consider this object creation statement, sorry, if you consider the object creation statement, I can say that we can broadly classify sorry we can just sorry we can divide this statement, object creation statement, into three parts. The object creation statement here, we can divide it into three parts, I can say. Yes. So what are those three parts here? The first part of the object creation statement is the declaration of reference variable. You see this part of the object creation statement, you know what we're doing? Declaring reference variable here. What we did? Declaring a reference variable. Yes. So you see, savings account space account. What is that account? Account is a variable. You see, this declaration is similar to something like this, int I. So what is I here? I is a variable. It is what type of variable, how you're saying, and what value we can say we can store in this variable. It is what type of variable and what value we can store in this variable. So it's an integer variable which can hold an integer value. So how we can say that it's an integer variable and it can take an integer value? This is data type, it specifies that, right? So similarly, account is also a variable like I. Account, please try to understand. Here, account is also a variable like I. But there is something special about this variable. What is it? It actually holds an object reference. So the specialty about this variable is that it holds an object reference, I can say. So what type of which object reference it can take? Which object reference it can take here? You see, it can take savings account object reference. It can only take savings account object references. Yes. Yeah. A reference is a kind of address to that object. Okay. Yes. Which points to that object, which we can use to access that object, I can say. Fine. This is about the reference variable here. Next we got new keyword. You see, In the object creation statement, this is the second part of the object creation statement, I can say. It is new keyword. Yes. So keyword means a predefined variable. Keyword means a predefined variable here. Yes. So why is this variable used here? This keyword used in the object creation statement. New keyword, it is used to request the JVM to create an object. Okay. Using the new keyword, we're asking the JVM to create an object. Yes. Using the new keyword, we are asking the JVM to create an object here. I can say. So that means it allocates a block of memory immediately whenever the JVM comes across this new keyword. It allocates a block of memory for that object. In other words, I can say it creates an object and returns that object reference. And what it does basically, it returns that object reference as well here. Yes. Okay. That is about the new keyword. Next, followed by the new keyword, you'll find that you got this statement, savings account. So can someone tell me what is it? Yes, that's right. Basically, it's a constructor. It's a constructor. So what is a constructor? Uh, I'll talk about it. Basically, it is not even a constructor, we say. It is actually a call to the constructor, I can say. So we are calling the constructor. What is it? Constructor. So basically, we are calling a constructor. So that part of that object creation statement, so which we have written here, it is nothing but it's a call to the constructor. It is a call to the constructor. So sorry, just a minute, please, just a minute. Yeah, sorry. So what is a constructor? Let's see. Constructor, I can say that constructor is a special method. Constructor is a special method whose name is same as the class name. Constructor is a special method whose name is same as the class name. Constructor is used to initialize an object. Constructor is used to initialize an object. So when I say initialize, what does that means? So we'll see, we'll talk about it. But as of now, just try to understand that it's a method, okay? And it is used to initialize an object, we'll see that. So the name of the constructor will be same as the class name. So these are the three things which you'll see in an object creation statement. Yes, assigning some values, that's right. So these are the three parts. The declaration of a reference variable, new keyword, which is used to request a JVM to create an object, and we got a call to the constructor here. Yes. So for suppose here, what if I do this? What exactly happens in this case? Can I say that an object is created here?
No.
I can say no. In this case, you see the object is not created. Yes. We only a variable is declared. This is just a declaration of a reference variable which can be used to store an object reference. We can store an object reference into this reference variable here. That's it. Okay. So an object is not created here in this case. For suppose, what if I do this in line number 8? So what it indicates? This statement.
We cannot initialize unless we declare.
So object is created. Yes, object is created. So what's the problem here? The object is created, but it is not. Uh, we are not storing that object reference anywhere. That object reference, you can say that we're not holding it. The program or this program has got no reference to that object now. Object is created, of course. Can we access that object? Can we access that object which is created in line number 8? I can say no. Of course, here the object is created definitely, but that object is which is created here, that object's reference, we didn't store it in a reference variable. That object's reference, it is not stored in a reference variable. So I can say that this object is a unreachable object. Okay. So this type of objects are unreachable objects, the objects which we cannot access. So generally there won't be any use here if I do this. Fine. So can I only use new keyword this way and ask the JVM to create an object? You can say this is not possible. It won't be possible, right? We can't do this. Yeah, we can't do this. This is not possible. So you can't do this. Fine. So this is how the object creation statement works. Now the thing is we need to understand the constructor here. So constructor, so I told you people, it is used to initialize an object. Constructors are basically used to initialize an object. Initialization means, let's see, initialization means assigning initial values to the instance variables which are part of the object. Okay, assigning some initial values to the variables which are part of the object, I can say. Yes. So the constructor is used for that initialization purpose, to initialize the object. That means assigning some initial values to the instance variables which are part of the object here. So did we write the initialization code here in this method? Can you people tell me? In this main method, did I write that initialization code? Can you people identify the lines here? In which lines did we write that initialization code? Which lines represent that initialization code here?
Line number 7, 8, 9.
Line number 7, 8 and 9. 7 to 9. And the line number 17 to 20. So we have written that initialization code here already, I can say.
Yes.
We have written that initialization code. But you know what? This is not the right way. The code which you have written here, this is not the right approach here. So actually, it is recommended that we use a constructor to initialize the objects. It is recommended that we use a constructor to initialize the objects here. So I will comment this code. Let's try to comment this code. And we'll use a constructor to initialize the object. Okay, but first of all here you say, I said we are calling the constructor. We are not defining the constructor. We are not creating the constructor here. We are just calling the constructor. So when I say we are calling the constructor, that means it has to be somewhere, right? So where is the constructor as of now? It should be in the class. So if it is a savings account class constructor, then it is supposed to be in the savings account class. But do we have a constructor here in the savings account class? I can say no. As of now, okay, but we didn't define it, right? So as of now, it looks like there is no constructor in the class. So if there is no constructor in the class, then how we are calling it? Yes. So you'll find that the compiler, when it compiles this class, it will check whether there is any constructor in the class. And if the compiler fails to find the constructor, if the compiler, if it didn't find any constructor in the class, you know what it does here? It will simply add a default constructor. Yes. During the compilation, you see, if the compiler fails to find the constructor, what it does? It adds a default constructor. That's a default constructor here. Yes. So how that default constructor looks like? How exactly the default constructor looks like? Let's see. You see, this is a default constructor. This is how it looks like. So the compiler will add this default constructor this way if it fails to find the constructor in the class. Okay. Yes. Now this is the constructor which we are calling here. This is the constructor, default constructor which we are calling here. You see in the default constructor, yes, there won't be any code. Now how do we use this constructor to initialize the object? So we can't use a default constructor. Instead, let's do one thing. We'll try to make use of parameterized constructor here to initialize the object. We'll try to make use of parameterized constructor to initialize the object here. You see, it's very simple and straightforward to add a parameterized constructor. Okay, and we'll use it to initialize the object. So if you're using Eclipse IDE, it's very easy. So please make a note of it. Adding a parameterized constructor using Eclipse IDE. Please make a note of it. Adding a parameterized constructor using Eclipse IDE. So as of now, this is a default constructor. Now we'll add a parameterized constructor. Yes. So what you need to do, right click on the class. I'm adding a parameterized constructor. Please make a note of it. Make sure that the cursor is in the class and right click on the class. You got source option here. In the source, you have generate constructor using fields. Please make a note of it. Okay, select this option, generate constructor using fields. I'll select it. So once you select that option, you should see a wizard here, see, which helps you people in this regard. What it says, generate constructor using fields, select the superclass, don't worry about it. You see down, you see select the fields to initialize, select fields to initialize. So you see the tool is able to identify the variables which you have declared in the class. It is identifying that variables, and you see here, now it will initialize, sorry, now it is displaying those variables here. So it is asking which fields you want to initialize. So we'll select all, let's say I want to initialize all the fields. Okay, and then you can click on OK. That's it. See, we got that parameterized constructor here. So you'll see super here. Delete the super. I'll talk about it later. It's related to inheritance. Now, what is the difference between the parameterized constructor and the default constructor? Yes. So the main difference here, you'll find that the default constructor, it won't take any values. There are no parameters for that default constructor. Whereas for the parameterized constructor, you got this parameters here. Yes. So what exactly these parameters they represent here? They represent the input values which we have to pass to this constructor when it is invoked. It takes that input values. What are those input values here? Int, float, and integer. Three values it takes. Okay. So the parameters here, they represent the input values here which this constructor takes. So when you call the constructor, you have to pass those three values in that order. Yes. Now that values which are stored here, that values, we can use them to initialize the variables, instance variables. We have to initialize the instance variables, right? So where are the instance variables? Where are the instance variables of fields? Where are the instance variables? Instance variables, they're part of the object.
Account number balance.
Instance variables, they're part of the object, right? You'll find that the instance variables here, they're part of the object. Now, how do we access that instance variables? What is needed to access that instance variables? Yes, just now we have discussed. So what do we need to access that instance variables? We need an object reference, right? So the constructor also needs that object reference. The constructor has to initialize that object. That means assigns that initial values to the instance variables which are part of the object. The constructor also needs that reference. So how the constructor will be able to access that object now? This is important. You'll find that whenever the constructor is invoked internally or implicitly, the reference to the object which has to be initialized by the constructor is also passed. The reference to the object which has to be initialized by the constructor is passed. You see, always that constructor is invoked as part of that object creation statement. Hope you have noticed it. Always the constructor is invoked as part of the object creation statement. So whenever the constructor is invoked, you know what happens? Implicitly, that object reference is also passed on here. Newly created object reference, which can be used to initialize that, which can be used to access that object. So where is that object reference stored? In this variable here. It is stored in this variable. Yes, this variable holds that object reference. It holds a reference to that object which has to be initialized by the constructor. Yes. Sorry. Now let me make use of this parameterized constructor. You see, we are calling default constructor so far. I will make use of parameterized constructor. You see, this is how you can do this. And similarly, we can do this. Yeah. So what we are doing, when I'm calling the constructor, I'm passing that values here, right? So the three values which are passing, you see, for the first time, you see, in that line 5, we are creating that first object. So as part of that object creation statement, you're calling the constructor. So once that object is created, the constructor is invoked, and that newly created object reference is also passed on to the constructor, and it is stored in this variable. Okay. Yes. So this now, it refers to that object which has to be initialized by the constructor. For the first time, when the constructor is invoked into this variable, the first account object reference is stored. So this variable is referring to the first account object, I can say. When we call the constructor as part of the first object creation statement, at that time in the constructor you got this variable. It refers to that first account object. And you see, we are using that reference, this here, to access that instance variables. This dot account number means you're referring to the top instance variable, which is part of that object. And then you're assigning a value which is stored in this parameters or variables, I can say. So now you see, we are calling the constructor again as part of the second object creation statement. So when we call the constructor as part of second object creation statement, so in this case, this variable here, it refers to which object? This variable, it refers to which object? It refers to the second account object, right? This variable, it refers to the second account object here. Yes. Okay. So the constructor will be called twice. For each object which you have created, each time the constructor will be invoked. And you see that this variable here, it holds a reference accordingly. Yes. Okay, so this way always the reference to that current object, I can say that it is passed on. So which is used by the constructor to access that object and initialize it. Yeah. Okay, fine. So have you noticed it? You see, the parameter names and the instance variable names are same. Are these two variables same or different?
Same.
Actually, these two variables are different. Okay, parameters are different and instance variables are different. So parameters, they're just local variables which you can only access them within the constructor. They're just local variables which you can access them within the constructor here. Okay, so that account number means you're referring to this parameter. So this dot account number means you're referring to the variable which is in the object. So parameters, yes, they're used to hold the values temporarily, and in turn, that values which are stored in this parameters temporarily, they will be assigned to the instance variables which are part of the object. That's it. Okay. Yes. So let me run this code once. Okay, we'll run this code. Yes, you see, it works the same way. So is there any advantage of using the constructor? What do you people think? Okay, let's go. So let me explain it. You see, uh, before we have used this parameterized constructor, how many lines of code did we write to initialize the object? 3 lines for each object. To initialize that object, we have written 3 lines of code for each object, right? So for 2 objects, we have written 3 lines of code additionally. We have written 3 lines. That means altogether for 2 objects, we have written 6 lines of code. We have written 6 lines of code here. Yes. For suppose, what if I have to initialize 100 objects? Then how many lines of code am I supposed to write here to initialize 100 objects? 300 lines of code. For each object, 3 lines, right? So for 100 objects, if you want to initialize 100 objects without using a constructor, in that case, you'll end up writing 300 lines of code. Or maybe you can reuse that variables also, but it will be little different again the case. But you see, additionally you have to write that code. So, but what if we use a constructor? So when you're using a constructor, so are we writing any additional code here? No. Simply as part of that object creation statement itself, you're calling the constructor, right? So that constructor has got 3 lines of code. So this 3 lines of code will be executing, and it will initialize that object. So you see, for both the objects, we are using the same constructor. For both the objects, you'll find that we are using the same constructor here. Yes. That means same 3 lines of code. So even if you got 100 lines of code, still, sorry, even if you got 100 constructors, sorry, not constructors, even if you have to create 100 objects, still you'll use the same constructor. So if you have to create 100 savings account objects, still you will be using the same constructor here. So you'll call the constructor. What we are doing, each time you create an object, you see, to initialize that object, you'll call that constructor. So as part of that object creation statement itself, you will call the constructor, right? Yes. So in a single line, you see, we are creating an object as well as we are calling the constructor to initialize that object here. So this is going to be an advantage, right? Yeah. So hope you people got it. So why it is recommended that we use the constructors to initialize the objects here. So any questions in this regard, please let me know. Yes, one advantage, reusability. We can reuse that constructor. So any questions? So, okay, good. So what about others? Okay, fine. Good. So what we did now so far, we are trying to just create a Java object to store a real world object details here. This we saw how to define a class, how to use the constructor to initialize the objects. So we got parameterized constructor, which helps us. Okay. So this class which we have defined here, with this class you see you got variables in the savings account class, and they represent the properties of an object, right? The fields, they represent the properties of an object. Here, similarly, we can also represent the behaviors of an object here. So that I'll discuss it in the next class. We'll see how to represent the behaviors of an object. Yes. So I'll stop it here today, and tomorrow I'll give you some assignments, some tasks, so that you can just work on it. Even if possible, I'll give you some exercises in the class itself to work with to make you people better understand this concepts. Okay? Yes, fine. Slowly we'll start implementing them. What are all the concepts which are discussed? Okay, fine. So let's meet tomorrow again and continue our discussion. Okay? Yes.